and welcome to the Arms Control Center. This is an introductory tutorial to EPIcode. The uses of EPIcode. EPIcode was developed to provide emergency response personnel and emergency planners with a software tool to help evaluate the atmospheric release of toxic substances. EPIcode allows fast estimation and assessment of chemical release scenarios associated with accidents from industry and transportation. The software can also be used for safety analysis planning purposes on facilities handling toxic materials. Additionally, this program can provide a rapid first-order check against complex and more data-intensive models. EPIcode will provide a reasonable level of accuracy for a timely initial assessment. More importantly, EPIcode will produce a consistent output for the same input assumptions and minimize the probability of errors associated with reading a graph incorrectly or scaling a universal nomogram during an emergency. EPIcode Library. The EPIcode library contains a library of over 2,000 chemical substances, along with the associated exposure levels accepted by various professional organizations and regulatory agencies. These include all of the current American Industrial Hygiene Association Emergency Response Planning Guidelines, also known as ERPGs, the Department of Energy Temporary Emergency Exposure Limits, known as TELs, and Acute Exposure Guideline Limits, also known as AEGLs. The EPIcode library also contains information on substances listed in the threshold limit values for chemical substances and physical agents and biological exposure indices published by the American Conference of Governmental Industrial Hygienists. Substance information is easily retrieved from the library by selecting either the substance name or common synonym, the U.S. Department of Transportation DOT number, or Chemical Abstract Service CAC number. Code basis. EPIcode uses the well-established Gaussian plume model, which is widely used for initial emergency assessment or safety analysis planning of a chemical release. Virtual source terms are used to more accurately model the initial distribution of material associated with explosions or fires. The Gaussian plume model generally produces results in good agreement with experimental data. Emergency preparedness requires a fast and adequate means of generating an initial assessment of an actual or scheduled atmospheric release. Just as important is the need for consistency in the assessment methodology, e.g., well-documented, consistent output for a particular set of input assumptions, etc. Actual source terms, the substances involved, meteorological conditions, etc., are seldom accurately known. Overly sophisticated and data-intensive models seldom provide useful and timely information in emergencies involving the release of or potential release of toxic material into the atmosphere. In the specific case of emergency planning and response, we are usually interested in worst-case scenarios, that is, if the plume of toxic material does reach a target community, what are the projected health effects? Unless specific accident scenarios are accurately detailed and proven to be reliable, large modeling errors are possible. Such errors render the use of large, complex and time-consuming models no more accurate than using a simple Gaussian model. The Gaussian model should be recognized as a starting place for analysis, and in many cases the only necessary tool due to the large uncertainty associated with a release scenario. The Gaussian model is still the basic workhorse for atmospheric dispersion calculations and has found its way into most governmental guidebooks. The Gaussian model has also been used and accepted by the Environmental Protection Agency. The adequacy of this model for making initial dispersion estimates or worst-case safety analysis has been tested and verified for many years. EPIcode strictly follows the well-established Gaussian model. EPIcode uses no black box techniques. All algorithms are presented and fully referenced. EPIcode uses the same algorithms and methodologies outlined in the Environmental Protection Agency document titled Technical Guidance for Hazards Analysis and Emergency Planning for Extremely Hazardous Substances. EPIcode output always contains all of the input assumptions and the calculated radii of the vulnerable zones in an exact agreement with the EPA document.